small correction to the introduction. I'm a co-founder of Zoid Labs, and the other two co-founders are also here, so you can feel free to interact with them. So we are talking about prototyping, electronic prototyping. Okay. So as we talk about prototyping, the previous talks have been about IoT. So there's a hardware element in IoT, and if you want to build it and test it, make it workable, you have to go through prototyping. So you have an idea, you want to go to the product, in between you have to go through prototyping. That's why it's very important to have that. And at Zoid Labs, we are enabling prototypers. So what our ideas are about prototyping, and what tools we supply you the arms to do the prototyping. That's our mission goal. Okay, so we'll get going. And I do electronic prototyping myself. So I would like to have a view of, how do I advance this? This button? Okay. Left to right? Okay. Okay. So that's the thing I was talking about. We have an idea, you want to go to a product, you have to go through several rounds of prototyping, right? So I would like to know from you guys, how many of you do electronic prototyping here? My hands up, yeah. Okay, that's interesting. That means I'm in the right room. Okay, so let's get into the details. And the context that I am referring to here is a difficult context where you have an idea, you want to bring it to the market, and your sun is setting, which means your limited resources. Okay, your team size is limited, your budget is limited, and your time to market is limited, and you're totally constrained, and you want to do it in-house, or you want to in-source. You don't want to outsource your design, your idea, because then somebody else will be running with it very soon. You lose control over IP. And you want to build the technology base, so you have to have the know-how. You can get know-how only by doing things by yourself. Okay, so that's the challenge context that we are talking about. And assuming there's a non-trivial level of complexity, the previous speaker mentioned about IoT hardware being open source. So if you can take something open and do it, then there's no complexity for you. So if there's a complexity, that's where the relevance of my points that I'm bringing before you come in. Okay. So, so my talk is in 6, 7, or 8 sections, which are listed here. I have only 30 minutes. So we'll go through an introduction. We'll look at prototyping strategies, activities involved in prototyping, what are the bottleneck areas, and we'll take a quick look at the assembly process for surface mount electronics, and some tips about process, how we can do it better, and what are the challenges you face while prototyping with SMT, and how can you reduce cycle time. I'll come to the stage where you will see that the cycle time is very, very important. It can make or break your work. Okay, so that's important. So we try to target that. And how do you streamline this with DFP? DFP is the word I'm using for design for prototyping. So you may be familiar with design for manufacture, DFM. So this similar thing, and some ideas have been brought together to call it DFP. Okay, what are those? We'll go into that. And what equipment do you need? What process support do you need? And the conclusion. So that is the overview of the talk. So we have 8 sections to go. So let's start. And what is SMT? If anybody is not familiar with SMT, that is surface mount technology. That's what the chips look like today. And SMT board, which uses surface mount, looks like that. And this is SMT mayhem. We are trying to solder a component using a soldering iron. You get into solder blobs here, shorts, and all that. Okay, that is the mayhem that you will face when you're doing prototyping. And when you try to remove the solder blob, you have to do solder wicking out and all that. You have even more mayhem. Okay, so this can set you back. So that is SMT, what SMT is roughly. And these are the component sizes which are being used, and these have shrunk today. So this is the through-hole component. You see 06, 03. That is this kind of size, 0.6. So that's 0201 size. That is over here, 0201. That is 0.6 mm by 0.3 mm. And the other ones are the more increasingly advanced modern sizes, 01, 005, and 008, 004. Those numbers are from mil. The specs are in mil. So you can look at 08, 004. That is 8 by 4 mil. So if your PCB is a 4 mil track, the width of this component is 4 mil. Okay, you can hardly see that thing, right? And imagine picking that with a tweezer and trying to place it somewhere. You're not going to do it. But for prototyping, we don't ask you to do 008, 0. Please don't do it. Okay, so that is designed for prototyping ideas, which I'll come to later. Right, so I'll check on the time. Okay, we are fine. So prototyping strategies, activities, and bottlenecks. That is the next section. Okay, and there are mainly 2 approaches to prototyping. One is the divide and conquer approach. That is, you're looking at a sub-circuit, you're building and testing a sub-circuit at a time. And this is more common and more relevant towards the early stage of your prototyping. where you want to isolate one channel or one circuit because your confidence level on that is low, you want to test that. So if you do this, you save. Efficient way of prototyping is to do sub-circuit first, okay, early stage. And you can also think of partial assembly. That is, you have designed a PCB, you don't assemble the whole thing at one go. Okay, you do partial assembly, and that speeds up your whole overall prototyping process. It gets you to market faster. Okay, the second approach is a big bang approach, which means you build and test completely assembled PCB. You can do that if it is like open source hardware, you are just building it. Okay, you have no doubts about it. You can do that. And typically, it's also used for product intent PCB that you build towards a late stage of prototyping. That means your confidence level is very high. You can straight away go into big bang. Okay? So this is how you should look at prototyping. And what are the activities? I'm sure you know about it. You start with circuit design. Your idea, you have to translate to a schematic with choosing the components and all that. Then you do your PCB layout. Then you get the PCB fabricated, or you fabricate yourself. And we'll recommend what is a good way. And you have to assemble the PCB, test it. So these are the activities which go on in prototyping. At every step of prototyping, you have to do initially all these things. Okay? And you have, why do we prototype? Because we want to learn something, whether your prototype works as you expected or not. So you have several rounds of prototyping. You'll end up having several rounds. And in the successive rounds, you may be modifying the schematic. And maybe you're modifying the layout. Maybe you're doing both. Maybe you're doing none of that. Maybe you have to only refab the PCB. Okay, some issue, or you're reworking the PCB, you're cutting a track, soldering a wire to some other place because you made a mistake, or that kind of thing, or you want to adjust some parameters, or you change some components and retry. That is reworking. And you may replace parts, reassemble the PCB, but you have to test again. Okay, so this is essential part of the bottleneck is testing. But I'm not going to address testing today. I'm going to talk about other parts. So let's say you have 5 iterations, and if a typical iteration takes 1 day, then you have 5 days. If it takes 4 weeks, you have 5 months. Okay, so that is why anything which is iterative is going to kill you. That is a bottleneck, going to hit you again and again. It's a monster that you don't want to leave it to be there. You have to slay this monster, right? And it's critical to have fast turnaround in prototyping. And cycle time can make it or break it. So this is also our experience. We have taken our idea and built a product, and the product is currently in beta. And to build this, we have to go through several prototypes. And cycle time is the key thing there. And we'll talk a little bit more about that later. And modifying schematic, okay, it takes a certain amount of time, modifying the PCB. But if you want to refab the PCB, usually you're sending it out, and it takes a little bit more time. Okay, so 2 clocks there. Or rework, hacking the PCB, making it what you want it to be. Replacing parts could take a lot of time if you're not familiar, and if you're using tweezer and the component flies all over the place. Okay, so this replacing parts and reassembling can be time consuming.